once again welcome you to this lecture series in soil mechanics or geotechnical engineering 1, and now I have completed your seepage and permeability and other topic before that. Now, I am going to the new topic, that is compaction of soil. This compaction of soil actually why it is needed, what is compaction, all those things I will discuss one by one. The soil actually we have classified at the beginning, and based on the classification of the soil we can decide or we can come to know that which soil is good, which soil is not good, which soil is bad, or which soil is reasonably good, which soil is reasonably bad. So, like that we can characterize based on the classification and other characteristics, but a good soil is good, that means there is no problem, one can construct or whatever desired infrastructure they want, but when the soil is bad, then how to solve the problem. And but there are two options. When the soil is bad, we can change the location, then I can go to a new place, new location site for project, or if that is not permitted because land is not so easy to get, suppose whatever the site, same site to be used, then what is the alternative? Alternative is that you have to make the soil suitable for construction. How to make suitable? There are many ways to make the soil suitable for construction, and one such method is the compaction. That means, by compacting the soil, one can make the good soil. So, that one actually and that means not only that, there are also different areas or different types of soil immediately looks to be good, but over the time they may create different types of problem. So, there is a in general we call it a problematic soil. So, there are different problematic soil in different region and different areas, and then those problematic soil actually immediately, if you know the soil is problematic, then generally we do not construct anything without doing any modification in it. So, that means we generally classify the soil as a problematic soil and good soil, and those problematic soil, what are the different problematic soil, what is their source, that I will show one by one, and what is their potential problems. So, these are the things actually naturally we can get potential soil, or we can get the field soil also problematic soil. So, when you get natural soil, there is a soil called soft clay. I have also mentioned before that soft clay is a very highly plastic soil and it undergoes lot of settlement. So, when it is a naturally obtained soft clay, it has low strength, it has high compressibility, it has large creep deformation and low permeability. So, these are all low permeability sometimes favorable, but other properties are not favorable. So, because of that, if we find at a particular site soft clay, then we may think of the modifying the soil. Similarly, silt is another soil where it also has a low strength, high compressibility, high liquefaction potential and low permeability and high erodibility. That means, during flow or if there is rain, soil can erode very quickly. Then immediately then another soil which is also available naturally, that is organic soil. It is also a very dangerous soil. It is high compressibility and large creep deformation. Of course, strength also is low, and loose sand is generally good, but if it is in a loose and fine, then there is a problem. It will have low strength, it has high compressibility and high liquefaction potential. So, similarly, if you get another type of soil where actually normally good, but when it come in contact, then it will swell and it cause the building to move off and sometime noticeable also, and when it will dry, that means in the dry season again soil contract, and as a result again it pull that foundation below downward. So, that means with season if the foundation is there built on expansive soil with seasonal variation, building sometimes goes up and goes down, and that way the structural damages takes place. And this lowest is another a particular type of rounded silt and sand, which I have explained at the very beginning. That is also very a problematic soil, that is large volume change and high collapsible potential actually. So, these are the naturally we can find this type of problematic soil. Now, if I go to the fill material, we can also different types of fill material is possible. If it is a uncontrolled fill, it will have uncontrolled, it is not proper filling, sometimes can be done, you put a layer and compact, put a layer and compact, then that is a controlled filling, and that will have desired quality for construction. Whereas, if it is uncontrolled and randomly is dumped different direction, then this type of soil will have low strength, high compressibility, non-uniformity, high collapsible potential. So, that is why it has to be handled properly. A dredged material, when it is dredging material, it comes in chunk, and if it is filled it, then it will have high water content, low strength, high compressibility. Then reclaimed fill, high water content, again low strength, high compressibility. Then recycled material, non-uniformity, high variability of properties, and if it is a solid waste, it will have low strength, high compressibility, non-uniformity and high degradation and property. And bio based byproduct, again low strength, high compressibility, high gradation, degradation potential. So, that means two types of material, natural or fill, but these are the identified material where if you try to construct something, you have to be careful. That means careful means what? Directly you cannot do anything, particularly if it is an important structure. What you have to do? You have to do some modification. After that, when it becomes suitable, then only one can make the desired structure. Now, we are in a topic of soil compaction. One of there are different ways soil can be modified. I will talk about soil compaction now. Compaction means actually what? To press closely together. Compaction means, so two particles, suppose you have to press them and then bring them closer, and if you do that particularly in soil, then soil it means they press the soil particles tightly together, expelling air from the void spaces. We have I have already done 3-phase diagram. I have shown that in the soil mass, if I model it, then I can get a solid volume and I can get the voids volume. So, that voids amount if I can remove, and if I force the particle to come closer, then voids automatically will be reduced, and by that way soil get densified, and densified soil will be better soil. So, that is what compaction, purpose of the compaction is to expelling the voids and bring the particles closer. And then consolidation also results in. So, there is another topic consolidation, which I will be discussing maybe later on. Consolidation also is a phenomena for saturated soil, and 3-phase diagram we have shown three situation. One is entirely dry, in that case air and solids, and there is in between, and then there is a other extreme, the entire voids is filled up with water and then solid. So, then when in consolidation case, actually it has to be saturated condition. When we somehow we manage to make the water to come out, then when water come out, then same amount of volume of soil also compress. So, that is also reduction of void ratio, and here actually in the compaction also we are also by some means we are reducing the voids and bringing the soil closer and reducing the volume, both the cases reduction in volume. So, consolidation I will discuss later on, but right now I am just mentioning consolidation also result in reduction in void ratio. So, compaction is reduction in void ratio, consolidation also reduction in void ratio, and consolidation and compaction are not the same, still they are not the same, because the mechanism is different. Compaction is instantaneous, that means immediately I apply force and bring the soil particles to closer and get compacted, whereas consolidation is slow process, that means you apply some amount of load. Because of that load on the saturated soil, the initially excess pore pressure will develop, and that because of this excess pore pressure water comes out through the interconnected void spaces, and when water comes out, then the same amount of volume of water coming out, the same volume of soil mass will be reduced. That is the one. And another thing difference, the compaction is instantaneous, and whereas this is consolidation takes a long time, and consolidation actually saturation is the essential condition, and whereas compaction it is not required. So, now soil compaction, what is the purpose? Purpose of compaction is compaction increases soil's density, and immediate effect what we get, the soil particles comes closer and density get increased, and that actually gives you several benefit, that is most important three are actually increase in shear strength and decrease in settlement, that means compressibility, and decrease in permeability. So, three. So, result of densification are this. These three effects are beneficial for the construction of various types of earth structures, namely highways, airfield, earthen dam, etc. Greater the compaction, greater is the compaction, the greater will be the benefits. The compaction is the cheap and effective way for improvement of the soil properties. That means, as I have mentioned that if you identify a problematic soil, that can be modified in different ways. One simplest way is that entire soil can be removed, and one can bring a good soil and fill it up. That is one way of course, but that sometime may not be feasible because of the cost. So, like that there are several other alternatives, and one alternative is compaction. So, this compaction why many times is chosen, because it is a very cheap and effective, and it is it is not required any specialized workmen, people for working, no need of very specialized equipment. So, because of that this is very popular. So, soil compaction typically we do by using different things. This is a roller, this is also sometime rubber tire roller, this is smooth wheel rollers, and this may be sometime plate compactors. So, different way on the soil we put a layer of soil, and then we can by some weight we can apply over it, then soil automatically will get compressed. So, that is the simple mechanism generally used in compaction. And plate vibrator, actually some soil, if I apply just pressure or load, sometimes soil will not get compacted, particularly soil granular soil. When we apply vibration in addition to the weight, because of this vibration the soil particles, actually smaller particles can enter into bigger particles and make more compact stable arrangement. So, because of that sometime this type of compactor is used, that means in addition to the weight we add some vibration. Compaction is quantified by its dry unit weight, which can be computed in terms of bulk unit and moisture content. So, we have actually at the beginning we have considered, we have done several things, actually we have done gamma d, we have done gamma bulk, and we have got expression relationship become gamma d and gamma b, relation is 1 plus w. This is done at the beginning. So, that is what. So, when we compact the soil, how to quantify the soil compaction, whether it is good bad, by measuring or by estimating or by calculating the gamma d. When this compaction is taking place, we go in some interval, we measure the or do some measurement and find out the dry density. When we see that dry density reach to a desired value, then we declare that compaction is satisfactory or compaction is done properly. So, that is what, that is the one, that is initially dry density we cannot do, we can find out in the field bulk unit weight and we can determine the moisture content. So, by knowing the bulk unit weight and moisture content, we can find out the gamma d by using this equation. So, that is the quantification, how we quantify the compaction, degree of compaction. So, some soil can be compacted with gamma d equal to 1.6, some soil can be compacted with gamma d with 1.7, some soil can be 1.8 like that. So, and 1.6 compared to gamma d 1.6, gamma d 1.8 definitely is a better compaction. So, in most cases dry soil can be best compacted if certain amount of water is added to it. So, dry soil if you compact, it will be compacted, but it will not be efficient. So, if you can add some amount of water on it, then that water will act as a lubricant and which will help the soil particles to come closer and pack together, and that way actually. So, you can some amount of water is necessary to add to make compaction efficient, but again if I add excess amount of water, that again will not give you the good results. So, after certain amount of water, it will reach the maximum dry density, but if you further add water, then again dry density again will fall. So, that is why in this actually compaction we get a every soil will have a particular characteristics when the energy level actually load or and other energy level is kept constant, then for a constant level of energy for a particular soil we will get a particular maximum dry density and corresponding maximum moisture content, at which it will give you maximum dry density, and those two terms actually is called this moisture content is called the optimum moisture content. That means, how much water we have to add, and by adding that you will get the maximum dry density. So, that moisture content is called optimum moisture content, at which actually you will get the maximum dry density, and the associated dry unit weight, that means, based on that amount of moisture content if you compact, and this resulting dry density is called maximum dry unit weight. So, that has to be specified most of the time, and this is actually if we test a soil, if soil is tested in the laboratory, and then generally we get a compaction curve. So, as I have mentioned that we have to we cannot add water excessively. So, you have to do trials actually initially. So, you have to start with some minimum level of water content, maybe 4 to 6%, and you have to compact. This for compaction there is a standard procedure. The procedure is given by standard Proctor, is the name of the person. He has given the specification for Proctor compaction, what will be the energy level actually. That means, there is a hammer, it will fall for a particular height. The hammer weight is 2.5 kg and it will fall from 30 centimeter, and you have to give in 30 blows, 25 blows actually, and then by that standard if you compact the soil, and then if you take the weight, bulk weight, and find out the unit water content, then from there we can find out the dry unit weight. So, suppose at 4% of water, suppose we have got 1 point, and based on that water content is exactly this and dry unit weight is this. Then again 2% or 1% we have added, and then we got another sample, compacted sample, and based on measurement we have got dry unit weight is this much. So, this is W 1 and this is W 2, and this is gamma d 1, this is gamma d 2. Similarly, at W 3 we are getting gamma d 3, at W 4 we are getting gamma d 4, sorry, gamma D, gamma T3, gamma D4, and this is W5, and this is gamma D5. So, like that we get a curve. So, how when we assume, or when you can ascertain, or you can come in conclusion that you are done test correctly. Generally, when you correctly conducted test, you should have actually 4 to 5 trials, and out of these 4-5 trials, 50% should be, nearly 50% should be wet dry side, and 50% should be wet side. So, if I take, this is the peak optimum moisture content. So, 2 points is in the dry side and 2 point side, 2 to 3 points in the wet side. So, how to during test, actually how we will be doing, when I will find out the bulk unit weight in a particular volume, and with a particular energy we compact the soil, then that volume of soil generally we take bulk unit weight. When we change the bulk, initially bulk unit weight also increase with addition of water, and it reaches to a maximum, and then bulk unit weight try to drops. So, always during test we have to take the dropping side 2 and lesser side 2 also. So, like at least, so that we will get a smooth curve like this, and from after drawing this curve, one can find out the optimum moisture content smooth curve. If you do, optimum moisture content is this, and gamma D max is this is the one. And of course, when we do the test, then soil is moist, but not saturated. So, because of that, during this test, if I can draw a 0 year void lines, that means when complete removal of voids is totally difficult, very difficult. So, theoretically you can draw a 0 year void lines. What it is, I will discuss later on, but this 0 year void lines will be somewhat parallel to the end of the curve. So, that is the convention, generally we have the standard, and it should be. So, whether your test is correct or not, by observing this we can decide. Now, as I have mentioned, when we conduct the test, we are talking about the energy, and we are talking about the soil type. So, some soil actually can be using a constant energy, can be densified to some dry density. If I take some other soil, you may not able to densify that amount by same energy. So, that means it depends on that compaction, that optimum moisture content and dry density, that is also that are actually characteristics of the soil. In a particular soil, we will have a particular optimum moisture content and a particular dry density. So, so that is what. And another thing is, if I change the energy again in the for the same soil, if you change the energy again, optimum moisture content and dry density also will change. So, that is the thing is explained through these two diagram, two figure here. You can see here, this figure is shown, 0 here void lines are here, and I have same soil with 20 blows applied, and this is the graph operand. When I have increased the blows to 25, I have got another curve here. When I have used 30 blows, I have got another curve here. When I have used 50 blows, I have got another curve here. So, like that you can see, with the increase of the number of blows, increase of number of blows means we are increasing the energy level. When you are increasing the energy level, then with the increase of energy level, you can see the compaction curve is shifting left side. Also, its dry density is also increasing. So, by observing this figure, what we can conclude, with the increase of the moisture energy level, your optimum moisture content is reducing. It was here, it is reducing. So, it is moving in this direction, optimum moisture content is reducing. So, that means, if you energy level if we increase with lesser effort, with lesser amount of water, we can achieve the higher density. And another observation, that means, with the increase of energy, optimum moisture content is decreasing, whereas with the increase of energy level and what dry density, it was dry density was here and next dry density was here, that dry density is increasing. So, that means with the increase of the energy level, your dry density will be increasing, but at a lesser moisture content. So, that is the observation, and here actually another one I have tried to show that when different soil if you test with the same energy, then you can see different curve you are getting. So, different curves actually you can see one well graded coarse fine sand, 2 is the very fine silty sand and something, then 3 is oxidized clay fill and 4 like that. So, you have when we will have the finer the soil particles, that means towards clay, then we will have optimum moisture content is higher and dry density is lower. So, you can see 7 is sandy silt, 6 is river silt. So, this figure actually is not different soil is shown. By this actually what we have explained, that different soil has different characteristics. By my conclusion or observation is, when you go from coarser to finer soil, so when soil is finer, then your optimum moisture content will be more and dry density will be less, and so that is the thing. So, clay soil will have this side and sandy soil will have this side. Okay. So, this is two observation we can make from this. And now, the soil compaction. I have several things I will discuss, but during for compaction generally different types of compaction is used. There is a smooth wheel compaction. The smooth wheel roller employs 2 or 3 smooth wheel rollers, and it is useful to compacting base courses and paving mixtures. It is also used to provide smooth finish grade, and smooth wheel rollers provides compacting effort through its self weight only. That smooth wheel roller, generally rollers are huge and is made of steel, and that weight itself will give you the compacting energy, and where actually these are suitable, these are actually it is useful for compacting base course, paving mixture, and also provide smooth surface. And then next one, this is another type of roller, that is actually smooth sheep foot roller. Sheep foot roller actually what it is, when actually when the soil is fine grained, I have mentioned that you need more moisture and less dry density. To improve the dry density, sometime we have to give more energy actually. So, to give more energy, what we can do, that roller actually you can see that roller actually end there is a extended part, there is a small hooks like. Okay. And when this roller will be moving through the soil, then it will be contact area will be small. When the contact area will be small, then there will be more pressure. So, that means more pressure means ultimately same weight will be acting on the small pressure, energy is more. So, that is one thing. If it is sheep foot roller, that means the projected rollers, if it is there, that is called sheep foot roller. Through that we can apply more pressure, that means contact area is reducing. Another thing is, since it is like spike like is there, it is having a kneading effect. So, when it is a fine grained soil, this is very much suitable. So, sheep foot roller consists of a drum and attached projecting feet. Area of contact between the soil and roller is less, causing greater compacting pressure, and it is also provides kneading action and is effective for compacting fine grained soil. So, that means when it is a clayey soil, this type of roller is good. And this is a pneumatic rubber tire roller, and the pneumatic roller consists of a number of rubber tires, highly inflated, vary from a small rollers to a very large and heavy. Most heavy pneumatic roller are towed, and some smaller ones self propelled, and clayey soil and silty soil can be compacted. So, what type of soil it is suitable actually? It is clayey soil and silty soil can be compacted effectively, and also suitable for granular soil containing small amount of fines, and this is the type of roller actually. These are the so many tires are there. So, large area it covers actually. And then the soil compact, there is another type of roller, as I have told that when it is a granular soil, by weight it generally compaction is not that effective. So, because of that, if you can provide some sort of vibration along with this weight pressure, then it become effective. So, this type of roller where actually we can, there is a moving element, while moving it also vibrates, that vibrates actually cause the particles from that particle adjustment, and also there is a pressure through this weight. So, these two together the soil get compacted nicely. So, a vibratory roller contains some kinds of vibrating unit that imparts an up and down vibration to the roller as it is pulled over the soil. Vibrating units can simply will supply frequencies to vibrate at this to this, and depending on compaction requirements, they are effective in compacting granular material that I have as already mentioned, and particularly clean sand and gravel. So, this type of roller are very good. This will have a vibration in this. And then there is some process, there is recommendation actually what type of roller will be, or compaction equipment will be used for what type of soil, that some guidelines. If it is a rock fill, your roller type is vibratory or rubber tire roller, second choice actually this. And if it is a plastic soil CHMH, then ship foot roller, as I have mentioned my previous talk slide, and rubber tire roller also can be used in the second choice, and thin lifts is desired. That means, at a time 1 meter and then compacting, it will not be effective. So, what you have to do when this type of soil, you have to put in layers, and that too should be thin. Low plasticity soil CLML, again ship foot roller, and rubber tire also can be used in the second choice, but not the first choice. Moisture control is critical. And plastic sands and gravels, then vibratory and pneumatic roller both can be used, and paired foot roller, that is also another which we have not discussed yet, that is also second choice. And silty sands and gravels, that is again vibratory roller, second choice is rubber tire roller, and moisture control is critical here. Clean sand, that is SWSP, again vibratory roller, impact and rubber tire roller also can be used, that we have not discussed yet. Clean gravels, that is again vibratory roller. So, rubber tire roller, impact grid roller, this is also I have some of them I have not discussed. Grid useful for, so this is also I have not discussed. So, this comment I will not discuss much here. So, that means, these are the different types of soil we may have while construction, and then what is our choice? The first choice are this, and sometime second choice, that with this type of equipment also can be used if sometime not available other type of equipment. Then this is ship foot roller. Generally what you have to do, ship foot roller, when it is there, applicability for fine grained fields or coarse grained fields with more than 20% fine, and compacted lip thickness, that is also given. Compacted lip thickness is given here, that is 150 millimeter thickness, and 4 to 6 for fine grained field, that means number of passes, 6 to 8 for coarse grained fine. If it is a rubber tire roller is then this type of soil, then 250 thickness. If this type of soil, that means fine grained fields or well graded coarse, then 150 to 200, and here actually 3 to 5 passes, here is 4 to 6 passes. And if it is smooth wheel roller, if this is the soil, then you have to lift, you have to give 200 to 300 and pass actually 4. And if this is the soil, fine grained fields other than earth dams, then thickness rise in each step will be 150 to 200, and it has to given 6 passes has to be given for reasonable good compaction. So, these are actually last 2 slides what I have shown how to choose the compaction equipment, and once you choose the compaction equipment, then what are the guidelines, that means how much thickness you have to put in each layer and how many passes you have to give. So, these two guidelines can be used for selecting during compaction. So, I think with this I will conclude today. Thank you.